Well, welcome to MV Tutors. My name is Fikakahle Manana, and we are doing now the Mathematics Paper 1 2022 November paper. Okay, well, let's just get started right now. Now, scroll down here. We look at our question 1. We're going to do this question step by step. Okay, let's do the 1.1.1. Okay, are you ready? I know I am. 1.1.1. So we are given 3x minus 6, x plus 2 is equals to 0. I know you know what to do here. You just simply go x is equals to 6 over 3. Now, you need to simplify this into 6 divided by 3 is what? It's 2. Or x is just simply equals to minus 2. That's it. Okay, let's do 1.1.2 now. And just to change the color of the pen, 1.1.2. All right. So we got 2x squared minus 6x plus 1. Well, we use the quadratic equation here. And in case you don't know it, if you scroll at the end of the paper, there we go, you will always be given the quadratic equation. X is equals to minus b plus and minus square root of b squared minus 4ac divided by 2a. Okay, now what you want to do is put an a on top of there, put a b top there, and a c there so that you know exactly what to substitute. Now minus, I like to put this in a bracket. B, my b is actually minus 6. So I'll put that in a bracket. Plus or minus square root of b. B is minus 6. It really doesn't matter at this point because anything squared is still going to be positive. But I'll just put it. A is 2. You can clearly see it. And then C is a positive 1. Okay, all this is under square root. And it's divided by 2 times A. That's A. A is 2 once again. Now, what you need to do here is put this in a calculator exactly as it is. So, I'll put the fraction minus, open the bracket, minus 6, start with the plus, we open the square root, another bracket, minus 6, close the bracket and square it, minus 4, open a bracket, 2, close it, open another one, 1, close it, and go downstairs. 2, open bracket, 2. Now notice I put it exactly as it is. And that's what I got. Remember our question said leave it in 2 decimal places. So I'm going to convert this to decimal and I get 2.82. Okay. Or x is equals to. Now, at this point, you just want to remove the positive sign and put in a negative there. So delete, put negative, let's go equal. We want it in decimal point. Remember, 2 decimals, 0.18. That's it. Okay, let's do 1.1.3 now. 1.1.3. And we've got x squared minus 90. It's greater than x. So what you want to do here is just bring the x to the other side so that it becomes minus x minus 90. Okay, and now we need our critical points. So we'll just factorize this, opening 2 brackets, right? Put x on both. Factors of 9, that will give us minus 1. That's 10. And 9. Which one is going to be minus? It's the bigger one, because minus 10 plus 9 gives you a minus 1. So that means that our critical points are x is equals to 10 and x is equals to minus 9. What you want to do with this is put them in a number line. Just a horizontal line is fine. Put the minus 9 is this side. We'll put the 10 this side. It's a positive graph, so it's going to look like this, passing those critical points. At this point, we go to the inequality sign. We want values of x that are greater than 0. So on the positive side, so if you put your arm or your hand over this horizontal line, you look above, you are going to see this area, which is positive, and also that area. Now, there are many ways to write this down. You can say it's values of x that are less than minus 9 and values of x that are greater than 10. So one way of writing it. Another way of writing this, well, there are many ways. You can say, because remember we're coming from negative infinity here to positive infinity there. So we can say x, put those inequality sign. The one on the left is minus infinity. The one on the right is minus 9. And put that inequality signs as well. The one on the left here is 10. The one on the right is infinity. A third way you could write this, you could say it's values of x, the element of, now open a circular bracket, minus infinity to minus 9, circular bracket because minus 9 is not included, and values of x. Okay, you could just put a union and write that again, but I'm just gonna say 10 to positive infinity. Those are 3 ways of writing it, and those are the correct answers. Okay, let's do 1.1.4 now. 4, and we are given x minus 7 square root of x is equals to minus 12. Well, with these questions, what you want to do is really just make the surd the subject of the formula. So what I'm going to do, I'll keep the x this side, I'll bring the 12 this side so that it becomes a positive 12, and then I'll take the surd to the other side so that it becomes 7 square root of x. From this point now, I can put brackets around everything and square them to get rid of the surd, because that's how you get rid of a square root, you square. Notice I square everything here. Now I want to start this side on the difficult part. Now, this is important. You must say 7 squared, which will give you 49. And then square root of x squared will just give you an x. Okay. This side, you need to expand this. Normally, I like to open 2 brackets just so that I don't like shortcuts, because it's easy to make mistakes with shortcuts. So I need to expand this and say x times x. That gives me x squared. X times plus 12 gives me 12x. And then 12 times x plus 12x. And then 12 times 12. Wow, what is 12 times 12? Well, at this point, I do need a calculator. I forgot what 12 times 12 is, but I'm pretty sure it's an easy number. 144. 144. Okay, now I want to bring the minus 49. Oh, let me just leave it this side. Okay, now I'm going to have x squared. 12 plus 12 minus 49. I want to bring it this side now. So I have 12 plus 12. Those are all variables of x or coefficients of x minus 49, and that gives me minus 25x, and then plus 144 equals to 0. Well, at this point, I can really do factors of 144. That will give me, 25, but I don't want to do that at this point. I just rather go straight into the quadratic. If you remember it, it's minus b, so minus, I want to put little a there, that's b, that's c, minus b. I'll just substitute at this point, which is minus 25, plus or minus square root of b squared, which is minus 25 squared, right? Minus 4ac, a is just 1, and then c 144, right? Put that in a calculator, divided by 2a, which is 2 times 1. Right, now let's bring in the calculator. We're going to say minus, open bracket, minus 25, close the bracket. Let's start with the plus, square root sign. Under the square root, we've got minus 25, close that, square root, minus 4 AC, and A is just 1, and C is 144. All right. And then we come downstairs, it's just 2 times 1. I'll just leave it as 2. And X is equals to 16. Or, let's go back, change that positive sign over there into a negative. So we delete that one, put a negative. Or X is equals to 9. Now, when it comes to surds, you need to check your answers, right? Because normally you can reject one of them. So the formula is, just to rewrite it again, we're given x minus 7 square root of x is equals to minus 12. We need to check them. Let's start with the 16. So under x, we'll put 16 minus 7 square root of 16. Let's put that in a calculator and see what it gives us. If it doesn't give us minus 12, we reject it. Okay, so it's 16 minus 7 square root of 16. Let's see what is. Oh, minus 12. Fantastic. So this one is acceptable. All right. Now let's check the other one. 9 minus 7 square root of 9. Oh, well, it's not looking good already. But let's do it. It's 9 minus 7 square root of 9. What does that give us? Ooh, look at that. It gave us minus 12. So we accept both of them. This is just a check. You always need to check surds. Always. All the time. Okay, let's do 1.2 now. It says solve for x and y simultaneously. Okay, and we are given 2x minus y is equals to 2. And then we're given xy is equals to 4. Well, let's give them numbers. Let's call this one equation 1. Let's call this one equation 2. Let's take equation 1 and make y the subject of the formula. So I'll just take y that side, 2x, and then I'll take the 2 this side. Minus 2 is equals to y. Okay, let's call it equation 3. That's fine. And then what we're going to do now is take equation 3 into equation 2, right? So how does that look? We have an x, and where we have a y, we'll substitute 2x minus 2, right? Is equals to 4. Now we got to solve that one. X times that gives us x squared, 2x squared. X times minus 2 gives us minus 2x. And we got that 4. I just want to bring it this side. It becomes minus 4 is equals to 0. Okay, now let's work with this one. Quadratic again. Or we can divide everything by 2 such that we're left with x squared minus x minus 2. Okay, now we can factorize this one very easily, isn't it? It's looking good. I love it. So x and x, it can only be 2 and 1. Now which one is negative? It's the bigger one, which is minus 2 plus 1, because minus 2 plus 1 gives you a minus 1. So x is equals to 2, because you always take the opposite side, and x is equals to minus 1, right? Now we need to go back to our formula for y. Remember, y is equals to 2x minus 2. Okay, now when x is 2, what's the value of y? So substitute 2 into there, and that gives us 2 times 2 is 4 minus 2, that's 2. Okay, let's do the same this side. Y is equals to 2x minus 2, that's the formula. Substitute minus 1. Okay, so 2 times minus 1 is minus 2, that's minus 4. Okay, so those are our values for x. Got that one. When x is that, y is that. And when x is that, y is that. That's it. Okay, let's do 1.3. And it says show that equation is even for all positive integer values of n. So we are given 2 times 5n minus 5n plus 1 plus 5n minus 2. Is that a minus 2? No, it's a plus 2. Yeah, it's a plus 2. Okay, so even if you don't know what to do with this question, what the English is asking you for, just go ahead and simplify it, and we'll see at the end what we can conclude. So this one is already fine. Let's separate this one into 5n and 5 to the power 1 plus, let's separate this one as well, 5n and then 5 to the power 2. At this point we can factorize because we see there's a common factor of 5n on all these expressions. So we take 5n out and we're left here, we're left with 2 minus here, we're left with 5 to the power 1, which is just 5, plus over here 5 to the power 2, which is, well, let me write it. I know it's 25, but let me just write what's left like that. And then what I want to do is just put this in a calculator. Okay, I'm just going to go 2 minus 5 plus 5 squared. What does that give us? Oh, 22. Now check this out. Now, you might know or not know, but any number multiplied by an even number is always going to be even. So we go back to the question. What did it show? That is an even number for all integer values. So we can conclude, therefore, any number or any integer, just to put the words that they use, multiplied by an even number will always be even. Be even. You can try it. Put any value there. The answer is always going to be even. Let's just try it. Let me show you what I mean. 5 to the power 1, or let's go 3, even if we put times 22. See the answer? That's an even number. It ends with a 0. And n can be any value. Even if we put 5, still an even number. Even if we put, I don't know, 8, still an even number. So any value that is an integer is always going to give us an even number, because we are multiplying with an even number. That 22 is the one that makes all the difference. I hope you understand that. Okay, let's start question 1.4 now. It says 1.4. It says determine the values of x and y given 3y plus 1 divided by 32 is equals to 96x. Cool. Now, here's the thing. Whenever you see surds, exponents, and you see big numbers like this, you want to convert each and every number to the product of its prime factors. So this 3 is already a prime factor, so it will remain like that. Now let's change this 32 to a product of its prime factors. Now if you look at this calculator, there is a way. It's just that this one is a bit outdated, but from this version onwards, you can find a product of its prime factors. For example, what we do is let's go with the 32. We go 32, and then you go equal. Here's the equal sign there, right? After going equal, what you want to do is go to fact, which means factorial, like not factorial, but factors. Fact, it's there, and it's orange in color, which means I need to go shift, because shift is orange, and then I press that factorial sign. It gives me 2 to the power of 5. Okay, so let me just write that. That's a prime factor. It's equals to. Now we need to do the same for the 96. So let's start the process again. First we'll hit 96, and then we'll go equals, right? And then you go shift, okay? And then you go fact there. And then it gives us 2 to the power of 5 times 3. That's what we're going to write. So it's 2 to the power of 5 times 3. Now this is 96 rewritten as a product of its prime factors. Thank you so much, calculator. We appreciate your help. Okay, so we'll put the x there, square root. Now everything is in prime factors. So what I'm going to do, I want to rewrite everything in one line. So I'm just going to say 3y plus 1. And then I want to bring this 2 on top so that it becomes 2 minus 5. I hope you remember your rules for exponents. You can do that. Just change the sign from a positive to a minus when you bring it on top. Here, first of all, I'm going to leave these inside, times 3. And then what I want to do is get rid of the square root by rewriting it. So remember the laws again. The square root means divide by 2. Okay, so this is an exponent. Actually should be a bit on top. So let me do that. This is misleading the way that I wrote it. It should be actually here as x divided by 2, right on top there. Now what I want to do is Okay, this one I will leave it as it is, 2 to the power 5. Now here's the tricky part here. What you have to do is multiply this exponent in, and then I'll start with the 3 because I started with the 3 this side, so it will be 3x over 2 times 2. Now look at this. This 5 is 5 times x to the 2 because they're both exponents. So it becomes 5x over 2. Okay. Now at this point, we got a base of 3 on the left, a base of 3 on the right, a base of 2 on the left, and a base of 2 on the right. Now, if you remember the laws of your exponents, if the bases are equal, then the exponents are equal. So I'm just going to go ahead and equate them. The first one I have is with the 3. So I got y plus 1 is equals to x over 2. Right? And then the other one I have this side with the 2 is minus 5 is equals to 5x over 2. Okay, now I can solve for x this side. I do some gymnastics, which means bring the 2 this side so that I have 5 times 2 is 10 is equals to 5x. Divide both sides by 5. Okay, and then what I'm left with is 5 divided by x, therefore is equals to minus 2. Okay, can conclude and leave it like that. Then I'll take that minus 2 such that I have y plus 1 is equals to, where I have an x, I'll substitute minus 2 over 2. And then I got a plus 1 is equals to minus 2 over 2 is minus 1. Then if I bring this 1 on the other side, it becomes minus 1, minus 1, minus 1 is minus 2. So y is also minus 2. Okay. Well, that was the last part of the question. Thank you so much. I hope you understood everything. We appreciate you. Please spread the word, like and subscribe to our channel if you enjoyed our content and you learned something today. Otherwise, thank you and enjoy the rest of your day.
Hello everyone and welcome to MV Tutors. I'm Tulu and I'll be doing question 2 with you guys. It's been a minute and a half. It's been a while indeed, and apologies. Life just got very busy, but we're back and we're here to help you prepare for your June exam. This is for matrics now, not for rewrites. Rewrites are already done. So those who are in matric, let's see what we can do. Okay, so question 2, 2.1. The first term of a geometric series is 14. Okay, so A is 14, and the sixth term is equal to 448. Now 2.1.1, calculate the value of the constant ratio R. Okay, so there's our formula and we're just going to substitute what we know and see what we get. So looking at T6, okay, so I'm going to get 448 for T6. Our first value is 14. R is what we're looking for. N is equal to 6 minus 1. So if we say 448 divided by 14 is equal to R to the power 5, and if we root to the 5 both sides, what answer are we going to get? Let me just get the calculator. And if we get the calculator, you will do this. Okay, so we have 448, yes, divided by 14, and we get an answer of 2. Okay, so our constant ratio is equal to 2. Okay, great. Now 2.1.2, determine the sum of consecutive terms, so they follow each other. Okay, whether it's T20, 21, 22, whatever, that must be added to the first 6 terms of the series in order to obtain a sum of 114674. Whew, that's a loaded question. Okay, so first of all, what is the Tn formula? We have a r to the power n minus 1. Let me just actually write what we actually have. A is 14, r is 2, and we have n minus 1. So now if I were to get the sum, so the number of consecutive terms must be added to the first 6 terms. Let us then use the sum of the first 6 terms. Okay, so that is a r to the power n minus 1 divided by r minus 1. Okay, so for the first 6 terms, we know that a is 14, r is 2, and n is 6. Okay, now if we work that out, we'll get the sum of the first 6 terms. So we have 14, and in brackets we have 2 to the power 6 minus 1. Okay, close the brackets, all over 1, and that is equal to 882. Okay, I have my thing in scientific notation. So 882. Okay, so that is the sum of the first 6 terms. But when we take the first 6 terms and those other consecutive terms, which we need to get the number of, we're going to get 114674. So now, let's say then we take this 114674 minus 882 in order to see what are we dealing with here. Okay, and we get an answer. What am I doing? Calculator. We get an answer 114,674 minus 882. Ooh, this calculator is going to be the death of me. Okay, so we get 113,792. Make sure when you get to exams, your calculator is in the right state. You don't want to be dealing with unnecessary things, okay? But Casio always works best. So this is the sum, right, of all those values. Now we need to determine n. Okay, so remember the sum formula? We don't know what n is. First term, r to the power n minus 1. And we have r minus 1. What will our first term be? Okay, so we know that the first term of this geometric series is 14, right? But remember, it gets a little bit complicated now because the consecutive terms that must be added to the first 6 terms. So we're going to take 14 and add it to the first 6 terms so that we can get the rest of the terms that need to be determined. Okay, bear with me here. You have your first 6 terms, right? T1 to T6, and you add them with some terms somewhere in this sequence. Okay, and when you add them, you're supposed to get 114674. All right, so if we had used 114674 over here, we can say A is 14, but because we are starting somewhere where we don't know, where we have 113792, our first term is going to be different. It's going to be the first 6 terms, right? The sum of the first 6 terms plus this 14 that we have, and we can continue working out the rest. So when we get A, we're basically going to say 14, which is the first term, plus 882, and that is 896. Okay, 2 is r and n minus 1, so that's what we're trying to, oh no, that 1 is not in the exponent, that 1 is actually below. Apologies for that. And you have the formula sheet with you, so please don't make this mistake. And it's going to be divided by 2 minus 1, which is just 1. So we can just really not write that at all. And so if we take 113,792, 113,792 divided by 896, we get 127. Okay, so 127 is equal to 2 to the power n minus 1. If we take 1 to the other side, we get 128, which is 2 to the power n. And if we work out what n is, okay, what's 128? 2 to the power 5, let me just check, because I know 128 is part of it. 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is 128. Okay, so 2 to the power 7, 2 to the power n, therefore n is equal to 7. Otherwise, you could have used logs. You're at that point where you do know how to use them, and then you get n is equal to 7. All right, so those are the amount, the number of consecutive terms that must be added to the first 6 terms. Where in the sequence is this 7 consecutive numbers? We don't know. We were not asked the positions. We were just asked the number. Okay, now 2.1.3, if the first term of another series is 448 and the sixth term is 14, okay, so now things are twisted. Calculate the sum to infinity of the new series. So what is the formula? Sum to infinity is a over 1 minus r. I am doing this from memory. I hope I'm writing the correct things. Let's just check in the formula sheet. So yes, it's a over 1 minus r. Okay, just checking. Just had to make sure. Okay, and yeah. So yeah, now it says calculate the sum to infinity. So we have a, it's equal to 448. Now we need to determine r. So let's just do that. T6 is 14. A is 448. We have r to the power n minus 1. So that's 5. So now we have 14 over 448. And r to the power 5. Alright, so let us work it out. We have 5 over there, 14, nope, 14 is on top, 14 over 448, no, this is not written properly. Let's start again. We have 5, and we start with our fraction, 14 over 448, and that is 0.5. Okay, it makes sense. The last time we calculated, r was 2. This is the inverse, so r is equal to a half. Okay, and as it should, because for sequences for series that are infinite, you should have r in between -1 and 1. So 2 wouldn't have worked. We needed something that was less than 1. Okay, so now we have 1 minus a half. And now we can work it out. In the numerator, we have 448. In the denominator, we have a half. So we have 896. Okay. So yeah, that is the sum to infinity for the new series. And now we get to 2.2. All right. So if the sum of that series, it looks arithmetic, is equal to that, determine the value of k. And how do I know that it's arithmetic? The unknown p is not an exponent, it's just like part of the line. Okay, I hope that makes sense. So now let's look for the value of k being the last value. All right, so whenever you deal with sums like this, sigma notation, please don't be scared. What it means is you have a term formula where it is a third p plus 1 over 6. Okay, and the sum of all of those terms will basically give you 20 and 1 over 6. All right, so what is the first term? I like to advise that whenever you get sigma notation, find the first 3 terms. So the first term is when we substitute 0 in the place of p. So a third times p is 0, so then we're left with a 6. Okay, now the second term, we will have a third plus a 6. I mean, you can really work it out in your mind. But for some of us who are quick with the calculator, we would then go and work it out. So we have a 6 and a third. So that's 0.5, 0.5, so that's a half. And then term 3 is when we substitute 2. All right, so 2 over 3. So a third times 2, that's going to be 2 over 3. So now we have 2 over 3 plus 1 over 6. Calculator malfunctioning. 2 over 3 plus 1 over 6. I wanted in fraction form, so that's 5 over 6. Thank you. Okay, so I have my first 3 terms. So then, what is my common term? So I have my first term, and I'm going to look for my d, because I've established that it is a arithmetic series. So a half minus 1 over 6, and I get a third. Okay, so even if I take 5 over 6 minus a half, I should be getting a third. Yes, so D is a third. Okay, and that is D. So I have A, which is 1 over 6. I have D, which is 1 over 3. And N, what is N? N is the top part minus the bottom part plus 1. So it's basically K plus 1. Now we can finally write our sum formula. And we're going to look for K. So sum formula will be N over 2. And we have 2A plus N minus 1D. Let's just make sure. Because, yes, it is 2A. N minus 1D. We gotta make sure. Okay. So now N is K plus 1 over 2. Our first term is 1 over 6. So N, remember, it's K plus 1. So we have K plus 1 minus 1. So we just have K. And D, we established that it's a third. We have a whole lot going on here. So we have a mixed fraction, right? If we're going to change this mixed fraction up into a proper number, let's see what we can do. So we have 20, 1 over 6, and that's 121 over 6. Okay, cool. So we have 121 over 6, and we're going to multiply by this 2 over here, so that we have K plus 1, and inside here we have 2 over 6, which is just really going to be 1 over 3, right? And then plus a third K. Okay, now why am I doubting that 2 over 6 is 1 over 3? I don't know. Okay, so now we're going to cancel out this 2. We'll be left with 3 in the denominator. So I'm going to multiply this K. I'm going to remove the brackets. Okay, so I have a third K plus a third K squared plus a third K. Okay, I'm seeing all these denominators are 3, so I'm going to multiply by 3 throughout. So I have 121 is equal to K plus 1 plus k squared plus k. So I can see here a quadratic formula is coming up. Okay, so k squared plus 2k, and then we have 1 minus 120. So it's going to be negative 1 minus 121, which is negative 120. All right, and 0, we have two brackets. Okay, let's see, k, and we have 12 and 10. 12 times 10 should be 120. Negative 10 plus 12. So k is equal to 10, or k is equal to negative 12. Negative 12. So it cannot be negative 12 because k has to be a whole number that is positive. And therefore we have solved for k, which is 10. And that is the end of question 2, I think. Let's see. Yeah, so page, yeah. No. Yeah, we're done with question 2. So I'll see you guys now with question 3. No, not now, later, tomorrow or something. Thank you for tuning in. Hello everyone and welcome to MV Tutors. I'm Tsulu and I'll be looking at question 3 as promised. And without even wasting more time, let's get to it. Thank you for all those who have been subscribing to our channel, liking our videos. We appreciate it and continue doing so and spreading the word about our channel. All right. So it is given that, I haven't even read the question, I'm already writing. It is given that the general term of a quadratic number pattern is Tn is equal to n squared plus bn plus 9, and the first term of the first differences is 7. Okay, what does that mean? So if we have T1, T2, T3, T4, you know we like having 4 terms at least for a quadratic pattern, right? And then we have our first differences over here. And we know that the first difference is normally the arithmetic sequence. So let's just say A1 for term 1 of the arithmetic series, TA1, TA2, term 3 of the arithmetic sequence. So they're telling us that the first term of the first differences is 7. So we know that is 7. That is what it all means. Okay. Now let's go to question 3.1. It says show that b is equal to 4. Okay, so this is the b that they are referring to. You might have a simple way of getting it. I'm going to go the long route. I know it's 2 marks, but yeah. So my long way is to say T2 minus T1 is equal to 7. If you have a shorter way, please do post it in the comment section for those who just want to get on about life, okay? And for those who are like struggling and are like, I don't know what's going on, hopefully this, what I'm showing you, makes sense. So for T2, I basically want to substitute 2 wherever we have n. All right, so I have 2 squared plus b times 2 plus 9. I'm going to subtract when I substitute 1 in the place of n. So I have 1 squared, which is just 1, plus b times 1, which is just b, plus 9. And that is all equal to 7. So 2 squared is 4. 4 plus 9 is 13, plus 2b is equal to, minus 1 plus 9 is 10. So minus 10 minus b, and that is 7. So if I put the like terms together, 2b minus b is just b. 13 minus 10 is 3, and that's equal to 7. Therefore, b is equal to 4. So that is the nice 2 marks. If you, like I said, have a shorter way of doing it, great. If you're going to do it the long way, make sure you are aware of the time spent doing this question. You don't want to take too much time. Okay, if you want to know how much time you should spend on a question, exams are out of 150, and so there are, yeah, total marks is 150. I'm deviating here, but I just want you to determine. So the marks is 150 and the time is 3 hours. In an hour, you have 60 minutes. So 60 times 3, you have 180 minutes. And if you divide that by 150, why am I using my hand calculator? Let's just do it on the calculator on the screen. So you have 180 minutes available, and you want to divide by 150 marks. So per question, you should be spending 1 minute or 1.2 minutes. Okay, so for 2 marks, you will then spend 2.4 minutes. That's why I say time yourself. Make sure you don't go over if you're going to do things the long way. All right. Cool. So we've shown that b is equal to 4. 3.2, determine the value of the 60th term. These kinds of questions are very nice because really it's just a matter of substituting 60 in the place of n. So you have 60 squared plus 4. Remember, we just got b, so it's 4 times 60 plus 9. It's a nice 2 marks that you're getting there. So 60 squared plus 4 times 60 plus 9, and that is 3,849. Okay, cool. Now 3.3, let's just take it up. Determine the general term of for the sequence of first differences of the quadratic number pattern. Write your answer in the form TP is equal to MP plus Q. So basically we are looking for the general term formula over here. Okay, TP is equal to MP plus Q, right? Remember, we also have that common difference there at the bottom. So my strategy here is to get the values for T1, T2, T3, and T4. Then we already know the first term is 7. It was given to us. But yeah, let's get the first 4 terms of the quadratic pattern. So we're going to start with 1. We have 1 squared plus 1 times 4 plus 9. So we have 14 as the first term. And the second term, let's just move this calculator here. So we're just going to substitute 2 in the place of 1. So 2 squared plus 2 times 4, and that is 21. And then the third term, like I said, it's always advisable to get 4 terms at least for a quadratic pattern. Okay, so we have 30. And then the last term we're going to check out is term number 4. And that gives us 41. So let's get the first differences. We know the first one should be 7. So 21 minus 14 is 7. 30 minus 21 is 9. 41 minus 30 is 11. Okay, so there we do have common difference is D. First term is 7. So let's use our formula TP. Don't use TN. TP, so our first term is 7 plus, I almost said n minus 1. Here we have P minus 1 and times D, the D is 2. Okay, so we have 7 plus 2P minus 2. Then our TP formula is basically 2P plus 5. All right, so in the place of M, we have 2, then P in the place of Q, we have 5. So we have it. Nice 3 marks. This question was actually quite straightforward. The last question, 3.4. Which 2 consecutive terms in the quadratic number pattern have a first difference of 157? So basically, TP being equal to 157, we're going to get 1 term, okay, for that. So basically, if you have whatever, let's say we are at T20 and then we have T21 and the difference between that is 157. They're basically asking for T20 and T21. So we're going to determine which one is which. All right, so let's just erase that. I was just making an example. So we're going to go to our TP formula, right, where we have 2P plus 5. In the place of TP, we have 157 is equal to 2P plus 5. So basically, we're determining P. Okay, and whatever P we get, so the position that we're going to get is back to our T20 and T21. Okay, we're going to get this 157 that we're getting here. So this P that we're calculating is going to be this term. And the other term, we're just going to add 1 to it. Okay, because they are consecutive terms. So, yeah, so we have 157. So basically 2P is 157 minus 5, which is 152. So let us go and calculate. Like I said, for those who can do it in their minds and are quick, that's great. That's absolutely like phenomenal. Some of us need the calculator. So we know term 76 and term 77 are the two consecutive terms in the quadratic number pattern that have a first difference of 157. Some of you are like, wait, are you sure it's 77? What if it's 75? You go and check, okay? You realize 3 marks, 1,2 times 3. I have time to check my answer, right? So let's check. So if you're like, nah, I know it's right. I'm not going to go and waste any more time on this question. It's okay. So 76 squared plus 4 times 76 plus 9 minus 77. Oh, no, I'm supposed to start with 77. Okay. So this is 76. Now let's do 77. So 77 squared plus 4 times 77 plus 9 minus that. And there we go. The common difference is one, not common difference, but the first difference is 157. Okay, so the terms are 76 and 77. And that's it for question number 3. See you guys next time.
Well, welcome once again. My name is Firarasha Manana, and we are now doing question number 4, the 2022 November paper, mathematics paper. We're on paper 1. Okay, let's get right into it. It says the sketch in the graph of h of x. Okay, so that's a hyperbole. Okay, I can see it. They gave us the standard formula for it without the numbers, the variables. So we're probably going to have to put those in. The asymptotes of h intersect at 1 and 2. So we've got the point of intersection. They give us those asymptotes and also these values of p and q. So question 1 literally says write down the values of p and q. Okay, let's do that right quickly. 4.1.1, the values of p and q. Now p has to do with the x, and remember when it comes to the x down there, we always take the opposite sign, so it's minus 1. And then the q then has to do with the y, so it's just a 2. Okay, it's passing 2 over there, and we take it exactly as it is, as a positive 2. That's it. Let's look at the next question now. It says calculate the coordinates of the x-intercept of h. So they just want the x-intercept, and every time we solve for an x-intercept, it doesn't matter what equation it is, but you always say let y equals 0. Okay, so I'm just gonna rewrite that equation. We already know that p is minus 1 plus q is 2. Okay, so I'll put those numbers in, and then I'm going to say let, since we're solving the x-intercept, say let y equals 0. So we put 0 under y, 1 over x minus 1 plus 2. From here, it's just a matter of doing some gymnastics. So I'm going to take this 2 to the other side. It becomes minus 2 is equals to 1 over x minus 1. And then I'm going to take the x minus 1. I'm going to cross multiply, bring it this side. It becomes minus 2 x minus 1 is equals to 1. And I'll multiply it in. minus 2 times x is minus 2x. Minus 2 times minus 1 becomes plus 2. That's equals to 1. Continue with our gymnastics. So we take the 2 to the other side. It becomes minus 2x is equals to 1 minus 2. 1 minus 2 is minus 1. So then my x, divide both sides by 2, becomes 1 over 2. Now, look at the question. It says coordinate. Coordinate has an x value and a y value. So we need to get the y value. But remember, we said let y equal 0. So our y value will be 0. Our coordinate, therefore, is going to be minus 2. It's the coordinate of, yeah, I thought it had a letter, but it's going to be a half and 0. That's our coordinate. Okay, let's look at the next question now, and it's going to be 4.1.3. It says write down the x coordinate of the x-intercept of g if g of x is equals to h plus 3. Okay, I want you to look at this with me. We know h of x is equals to 1 over x plus, we solved it above. No, it was minus, but let me just put p this time, q. So now h of x plus 3, which is what we're looking for, that means where we have an x, we replace it with x plus 3, and then it's gonna be plus p here, and then q. So conceptually thinking about this, remember whenever we put a number here, it's a shift on the horizontal axis. Okay, and if it's a plus, it's a shift to the left. Okay, because remember, we changed the sign for it. So if we look at this, originally, and they're talking about the x coordinate of the x intercept. So we're talking about the x intercept. Currently, our x intercept, we just solved it, is equals to a half. Okay, but now if it's gonna shift towards the left by 3 units, that means we must subtract that half with a 3, and that gives us what? So we've got a half, that's 1 over 2, come downstairs, and then minus 3. Our new coordinate is minus 5 over 2. Okay, well, I hope you really understood what just happened. Let's do the next question now. It's gonna be 4.1.4. Okay, it says the equation of an axis of symmetry of h is the positive gradient one. Remember, there's two equation of symmetry. There's a positive one and a negative one. So they give us the positive one, determine the value of t. Okay, so we know that taking the positive one, it's y is equals to x plus t. To solve for t, we need to put in one point where this graph is passing, and we know for sure it's passing the intersect, okay, which we have been given as y, the intersection. Look at me saying y is equals to x, but it should be 2 there. So that's, I like to do this exercise where I put the little x and y on top. Now I know Where there's a y, I substitute a 2, and where there's an x, I substitute a 1. Got a t there. Do some gymnastics by taking this one to the other side. Therefore, 2 minus 1 becomes 1. That's our value for t. That's all. Okay, let's do 4.1.5 now. Determine the values of x for which, okay, so we're given minus 2, so inequality sign, 1 over x minus 1. Now, what I want you to notice here is that our graph of h of x has the same numbers. The only difference is that the 2 is on the other side. So if I bring that 2 on the other side, look at this. It becomes 1 x minus 1 at the bottom and then plus 2. This is our equation for h of x, which is this graph that we're looking at right now. Now, also I like to represent this with let me just put y, because this whole thing is y. It's h of x can also be a y. And the reason I put y there is because it makes more sense to say now I'm looking for values of x for where y, if you read this inequality, it means where y is greater than 0. Okay, so values of x for where y is greater than 0. So I know that if I put my hand over there, my fingers on my arm over the x's, and I look above, that's where I get values of y that are greater than 0. Because from here, from 0 going up, those that is the place where basically y is greater than 0. So if I'm looking for x values, I can see if I put my arm on the axis that, and I look above, I can see the graph starting from let me put the inequality signs, starting from negative infinity all the way up until this x-intercept here, which we solved to be a half. But also, if you notice, there's an asymptote here. I can also see the graph from this asymptote of from 1 all up until positive infinity. So I will in fact have two answers here. So this time I'm starting from 1 all the way up to positive infinity. Now here's the deal here. This inequality sign also has an equal sign, so I should actually put an equal sign there and also over there. Okay, now if I put it there, I won't be wrong, it's still correct, but well, infinity, it gets a bit tricky with infinity, because if I'm to rewrite this in this form where I say not like that, I want to write it and say values of x is an element and it's starting from negative infinity to a half. Now the half gets a square bracket because it's an inequality sign. However, with negative infinity, we never put a square bracket because it can never be equals to infinity, even though in theory or in practice it can, but it's just a general rule that infinity never gets a square bracket. So this one would be square bracket 1, that's a number, and infinity infinity, it's positive infinity. Okay, now let's talk about this again. even though it's greater or equals 2, but the fact that we have an asymptote, we know that the graph does not touch 1 ever because of the asymptote. So what I'm going to do then is just I'm going to rub that square bracket and put a circular one because of the asymptote. But because the half, it includes it because it touches it there and it's not an asymptote, so we include it. Okay, so that's how we are going to write it. But in this form, then I would rub this inequality sign over there and also rub it there and also rub it over there, such that I'm only left with it over there. That is still a correct answer. Okay, let's look at the next question, 4.2. The graph of f of x, they give us the entire graph. It's this quadratic one, I see it. And g of x, well, it's incomplete. They didn't give us a and q, are sketched below. E and h are the x-intercepts of f. Where's E and h? There we go, E and h, I see them. C is the y-intercept of f and lies on the asymptote of g. C, y-intercept and the asymptote. Okay, they meet there, I see. The two graphs intersected D, the turning point of F. Okay, they meet there. Okay, cool. All right. First question, write down the y coordinate of C. Okay, so what do we know about C? We've been told that C is the y-intercept of F. How do we read off the y-intercept of a quadratic function? We just go over there. That's the C value, which is the y-intercept value is just -5. That's it. Let's look at the next question, which will be 4.2.2. It says, determine the coordinates of D. Now, what do we know about D? The two graph intersected D, the turning point of F. So it's a turning point of F. And we know to get the turning point from a quadratic function, the x part is just -b over 2a. So we can tell from the graph, the b value is a -4 divided by 2, and the a value is 1. Okay, so put that in a calculator. It's just 4 divided by 2. 4 divided by 2 is just 2. So that's the remember, they want the coordinate as x and y. So to get the y value, we have to substitute this x value to the original equation. So it's going to be 2 squared minus 4 times 2 and minus 5. Let's put that in a calculator. Okay, so we have 2 squared minus 4 times 2 minus 5. Okay, we get it's -9. So our coordinate at D, which is the turning point, so we just write D, the coordinate, the x value is 2, the y value is -9. That's it. All right, let's look at the next one, which will be 4.2.3. Says determine the values of a and q. A and q, we can see it's the exponential graph. We know that the value of q, if you know your properties, is the asymptote. So the asymptote passes at c, and we have the value of c, which is the y intercept. We actually solved it here, -5. So q is just simply -5. Now if we rewrite the equation of g, it's y is equals to a 2x minus 5, because we just solved q to be minus 5, we'll just put it. Now, all we have to do is substitute a point where this graph passes, okay, the exponential graph passes, to solve for a. So that point will be the turning point that we just solved up here, which is 2 and 9. We know it passes there because we were told the two graphs intersect at D, the turning point of F. So we know that the exponential graph also passes there. I like to do this exercise where I put a mini x and a y on top, because now I know where I have a y, I put a minus 9. It's equals to a times 2, and I know where there's an x, I put a 2 minus 5. Now it's just a matter of doing gymnastics. I'm going to take this minus 5 to the other side. It becomes minus 9 minus plus 5, which gives me minus 4 is equals to a. And 2 to the power 2, I know that's 4. So continue with gymnastics. I know that a is 4 divided by minus 4 divided by 4, which is minus 1. Okay, so that's the value of a. I got it right there. The value of q, I got it right there. That's all they wanted in the question. Okay, let's look at the next one now, which will be 4.2.4. Okay, it says write down the range of g. Range of g, we know when we're talking about range, we're talking about the y values for which the graph is there. Okay, so we know that's minus 5 there. So really the graph, there's many ways of writing this, but I'll just stick to this one. It starts from negative infinity to what's that asymptote minus 5. That's it. That's the range of g. Okay, let's look at the last question now. It says determine the values of k for which the value of f of x minus k will always be positive. Now, I want us to think of this question conceptually. Okay, we know that this k is just a shift. Okay, so when we have 4.2.5, we know that this value of k is just a shift, and we have been given f of x, which is the whole function. We're looking at the parabola here, minus k. So we want values of k that will make the graph always positive. Now we need to ask ourselves, when is this graph always positive? It's always positive if it moves from down here and comes up there. Like let me just show you this thing. Currently the graph is down here, but if it moves to up here, then the values then the graph is always positive, because currently they are negative. It's negative from this point, from that point to that. So it's negative right here, right? It's negative all over there, and then it's only positive, okay, over there, right? But if it moves up to there, then it's always positive, always positive. So how do we get up there? What do we need to shift by? Now currently we know that if we go to our turning point, where we solved our turning point right here, it's 2 and negative 9, which means the graph is at negative 9 here on the y axis there. It's on negative 9. So to make sure it moves up, okay, it has to move up by at least 9 points, 9 units. Now the equation that we're currently given is that one there. And to make it move up, currently this minus is moving it down, which means to move it up, we must put a negative, a number, so that a negative and a negative makes it move up. And then all of a sudden it becomes positive 9. Okay, and that's the shift up. So 9 and upwards will make sure that the graph is always positive. Okay, so we're gonna conclude here and say k must be greater or equals to 9. So any value that is greater or equals to 9, but watch this out, the k has to be negative. Okay, because we are currently given a negative sign there. To make it positive, the k has to be negative. So any value that's greater or equals to -9 will make sure that this graph is always positive. Well, that's it from us. Thank you so much for tuning in. We really appreciate it. And if you enjoyed this content or you learned something, please like and subscribe on our channel. We really appreciate it. And share with your friends. Share with your friends. Please do. Other than that, enjoy yourself. It's goodbye from me. Well, hello there and welcome to MV Tutors. My name is Fikakahle Manana and we are still doing Paper 1 to the 2022 November examination. Now, let's look at question number 5 now. It says the graph of g of x. There's the, okay, I see the g of x, there it is. And then they give us the inverse of g. Are shown in the diagram below. Okay, D and B are the x and y intercept respectively of g. So I see D there, I see B, okay. C is the x-intercept of, okay, the inverse one. I see C there. The graph of G intersects at A. Okay, I see the intersection right there. Okay, so what's the question? Question is, write down the y coordinate of B. Wait, B, okay, we have that formula there. B is the y intercept. You can just simply just read it off from there. So that's 5.1. The y coordinate therefore is, we know we always start with the x value, which is 0, and which is read it off from there, which is 6. That's the y coordinate. They wanted the coordinate. So unless you do this, you don't get full marks. Let's give it in coordinate form. The next question is 5.2, and it says determine the equation of the inverse of g in the form mx plus n. Okay, that's cool. So we know that the original formula is equals to y is equals to 2x plus 6, right? So the first thing you do whenever you're doing an inverse is to swap x and y. That means where there's a y, we put a x, and where there's an x, we put a y plus 6. Everything else remains the same. Now we have to put and make y the subject of the formula. So we just need to do some bit of mathematical gymnastics. And what's that? That's just numbers jumping from one side to the other. So let's start with the 6. When it goes that side, it becomes x minus 6 is equals to 2y. Continue with gymnastics. We need to get rid of this 2. Divide everything by 2, just like that. Okay, and then we'll have this side, we'll have y. This side, we will have x over 2 minus 6 divided by 2 is 3. There we go. Okay, if you want to rewrite it, being the y this side, you could do that. It's really up to you, no problem with it. All right, so let's look at 5.3 now. It says determine the coordinates of A. What's A? Oh, A is a point where the two graphs intersect. So that's 5.3. The first graph is 2x plus 6, and the next one, which is the inverse one, that's where they meet, it's gonna be this one. So it's equals to x over 2 minus 3, which is equate the two graphs. Let's solve for x, see what x gives us. So I'm going to bring the variables, which is the x's on one side and the numbers on the other side. So here I will have 2x minus x over 2 is equals to, the side I'm left with, minus 3 minus, if I take the 6 that side, it becomes minus 6. Okay, well, so what's 2 minus a half? We know 2 minus a half is 1.5. So I can just rewrite it as 3 over 2. X is equals to minus 3 minus 6. What is that? It's minus 3 minus 6 is minus 9. Now I need to get rid of these numbers, this fraction rather. Okay, so how am I going to do that? I will cross multiply with a 2 to get rid of the 2, and then divide with a 3 once. It's like a reciprocal of that. Do the same this side. Let me just show you what happens. 2 over 3. That 3 cancels, that 2 cancels. I'm left with an x. And then I put this in a calculator. Let me just put it in a calculator. You know what? Let me not do it in my head. I got minus 9 times 2 divided by 3. Okay, that gives me minus 6. Okay, now check this out. Let's say determine the coordinate. Remember, coordinate comes with x and y. So I just solved the x part. I need to solve the a part now, the y part, sorry. So I can put it in any of these equations. Okay, so I'm just going to take 2 minus 6 plus 6. I'm taking this equation. It looks a bit easier to work with. So that's 2, open the bracket, put minus 6 in there, close it, plus 6, and my final answer is, wow, look at that, minus 6. So now the full coordinate, we look at it, coordinate of A, okay, the coordinate of A now, we solve the x part to be minus 6 and the y to be also minus 6. That's it. Okay, let's look at 5 point, what is it? Where are we? 5.4 now. Right. It says calculate the length of AB. AB. Okay, for that we need the distance formula. For the distance formula, you just scroll down to your information sheet there. We look for it. They always give it to us. We always, there it is right there. So I'm just going to write it exactly as it is first, the distance formula. You got x2 minus x1, close the bracket, square it, plus y2 minus y1, close the bracket, squared, and all this is under 1 square root. Okay, now back to our question. A and B. So what I want to do is to write the coordinates of A, there they are, and also just want to put the coordinates of B here. B, we solved it above, if you remember, there, 0 and 6, that's B, just 2. And those are the coordinates of B. So what I want to do is that I want to put the coordinates of B there, which is 0 and 6. Okay, now I'm gonna put that, open my square root, x2, 2 will be B, and 1 will be A. So I'll put little x and y there so that I know my values I'm reading. So x values, x2 is 0, minus x1 is minus 1, minus 6, so I'll put minus 6, and then I square it, plus y2 is 6, minus y1 is minus 6 squared. Shut that down. Now, I like to put this once in the calculator. So, exactly as it is. 0 minus negative 6 close square plus open brackets 6 minus negative 6 close square equals, let me put it in decimal form. Let me write it in surd form first. 6 square root of 5, and in decimal, that's 13.41. But I was not told to leave it in decimal. So in this case, we leave it in a surd form. Thank you. Well, let's do question 5.5 now. That's the last one. It says, calculate the area of triangle ABC. Okay, so there's a line joining B and C there. Now I just want to do a quick construction there to say that it looks something like this, right? Between B and C, something like that. Okay, can you see that? I hope you can. Now I want to introduce a construction line there, and I want to remind you that the gradient formula is equals to tan beta, right? I hope you remember that. So, and this gradient has to do with this angle has to do with the angle of inclination. Okay, so it's the angle there. That's our theta right there. Now, to solve this angle here, I also need, I'll call this one beta, that angle, that big angle there. I'll call it beta. And then the one that we're looking for will be this green one. I'll call it, this blue one, I'll call it alpha. So to get angle alpha, I need to take angle beta and subtract angle theta so that I get angle alpha. And then once I have that, then what we're going to do, we're going to go to our area formula, which is right here. We just need to find it. Where is it? Where is it? Area formula, you should be somewhere close. Can't be far. Do you see it? Oh, there's our tangent, our gradient one, and then our area one. There it is. So our area one we are given is the area formula is equals to of ABC, of triangle ABC, it's half A, B, these are sides, and sine C. I'm reading the wrong thing. Sine C. Okay, so this is an included angle. So that would be, let's call this one A, side A, and then that's side B, and then the angle C is alpha. Okay, then we get the thing. Now, if we go back to the question real quickly, that's question 5. We have solved the distance from A to B right over there, and it's 6 square root of 5 units. That's B. Okay, so let me just put it in my triangle because I like to put everything I need at once. So that's 6 square root of 5, which means now I need to solve for A. Fortunately, the calculation for A is exactly the same, well, almost similar to B, but let's just do it. And the coordinates, once again, we have the coordinates of A, because remember it's A right here, and then it's C over there, and then I want the distance between A and C, I know the coordinates of A are -6 and -6, and the coordinates of B, of C, let me rub that. We want to write it as C. Coordinates of C are 0. No, it's not 0. It's 6 and 0, because you start with the X. 6 and 0. How do I know that? Because it's the inverse of G, and X becomes Y and the Y becomes X. So if the Y was 6 here on B, the X is 6 on the inverse. Okay, so putting those in the distance formula, which will be, this is my 2, it will be 6 minus -6 squared plus 0 minus -6 squared. I put this in a calculator, I will get the same value of 6 square root of 5. So that's also 6 square root of 5. So now I have the two sides, A and B, to plug into the area formula. Now I just need to solve the angle of C, which is alpha in this case. Okay, so how am I going to do that? I'm going to start with the gradient is equals to tan theta. I know the gradient of this line AC. We solved it already. If we can go back up here, there it is. It's a half 1/2. That's the gradient. So under gradient, I put, you guessed it, 1/2 is equals to tan theta. Now I can solve for theta, where theta is equals to the arctan of a half. Now we need to put this in a calculator. So we're gonna go 10 and put a half. Put it exactly as it is, like that, so that you are not confused. Now, oh, watch out for that. You need to go to the side and close it. And we get that it's 26.5. I'll just take 2 decimals. No, let me take 3, just for control. Okay, now I want to do the same for beta, tan beta. Now the gradient for this line A, this line is AB, right? That's AB. The gradient there, we solved it once again, and it was this one, 2. So the gradient is 2 over there. So then we will put 2 this side is equals to tan beta. Now to solve for beta, then it's the arctan of 2. Let's put that in a calculator. Okay, so arctan 2, close the bracket. What do we get? Get that beta is equals to 63.435. I'm taking 3 just for control. Now, to solve now the alpha angle, which is coincidentally C, the angle of C, we need to take alpha is now equals to beta minus theta. And beta was 63.435 minus beta, which is 26.565. Now let's put that in a calculator. 63.435 minus 26.565. Okay. So that angle there is 36.87. Okay, now I can go ahead now and solve the area, which is a half A B sine C, which is alpha. Okay, a half. Now A, we solved it. We said it's 6 square root of 5. So we put it there. Oh, my bad. What did I just do? 6. Let me just check back. Oopsie. Okay. It's 6 square root of 5. 6 square root of 5 times B is also 6 square root of 5 times sine. The angle C is 36.87. Put all of that in a calculator. Go downstairs, put 2. Come here, open the bracket. 6 square root. Where's the square sign? Square root 5. Come here, close it. Let's open another one. Ooh. Oh, no. What am I doing? Close it. Now open another one. And let's put 6 square root of 5 again. Go to the side, close it, and then it's sine 36.87. Close it. So that equals to 54. That's the area, units squared. Right. Now that, ladies and gentlemen, is the area of triangle ABC. Well, I hope you understood, but that comes to the end of the question, and I really hope you grasp the concepts we're doing here. And if you did, and if you understood at least one thing, please like and subscribe to our channel, share it with your friends. We would really appreciate it. Other than that, thank you so much for watching and learning. It's goodbye from me. Enjoy the rest of your day.
Hello everyone and welcome back to MV Tutors. I'm Solo and I'll be looking at question 6 with you guys. And yeah, thank you for tuning in. Thank you for subscribing. Thank you for liking our videos, and we look forward to your comments in the comment section. If you have simpler ways of doing things, please do share so that others know how to save time. And now we are looking at question 6, financial maths. I hope you take this topic very seriously, especially in the financial climate we're in. I hope you're starting to invest now so that you can learn. I don't think you can take out a loan at your age, but investment is a good place to start to understand interest rates and. Okay, so 12,000 Rand was invested in a fund that paid interest at M% per annum compounded quarterly. After 24 months, the value of the investment was 13,459. So what do we know? We know that P is equal to 12,000 Rand. Our interest rate is M% compounded quarterly. Our N is 12 months, right? But they said quarterly. 24 months. Why am I saying 12 months? 24 months. 24 months is 2 years. So if we take those 2 years, so let's say a year, we divide it into quarters. We're going to divide this actually 24 by 4. Not by 4, by 8 actually. Okay, let's see. In 1 year, you have 4 quarters, right? And in another year, you have another 4 quarters. So in total, you have 8 quarters. Ooh, making things difficult for myself. Now I want to go calculate things. So we have 8 quarters in total. Yeah. Okay, and then at the end, the accumulated amount would be 13,459. So we're going to use our normal compound formula. All right, so we have the accumulated amount is equal to the principal amount multiplied by 1 plus the interest rate to the power n. So we basically have everything that we need. I'm just going to put this in a border. So A is 13,459. P is 12,000 Rand. 1 plus the interest rate, which is m% over 4, and n is 8 quarters. So let's do some maths gymnastics. Took that from a fellow tutor who's very well known in the YouTube space. Okay, so if we want to get rid of the exponent 8, we're going to root it to the 8. Okay, and then what do we get? So this is where our calculators come in and they feature. So shift, and we get that 8. We're just gonna put everything as it is in the calculator. We don't want to complicate our lives. Okay, and so we get an answer of 1, 0, 1, 4, 4, 4, blah blah blah, and that is equal to 1 plus the 8 is gone. The 8 is gone. Okay, my eraser doesn't want to work. Okay. Yo, my laptop is now malfunctioning on me. Okay, what is happening? I can't erase. Alright, guys, let's just see when technology fails. So we have 1 plus m%. The show must go on. Okay, so then we subtract 1. If we take 1 to the other side, we subtract it, and we are left with 0, 0, 1, 444, blah blah blah, and we have m% over 4. Okay, so we're going to multiply by 4 on both sides. So we then get 0, 0,5778, and that is equal to m%. Okay, they said they wanted m, not m%, right? Determine the value of m. So then m, no, seriously, something is up with my, I'll have to pause after here to fix this technical glitch, but we need to multiply by 100 basically, and we get that m is 5,78%. See you guys in the next question. I think the technical glitch is fixed. We can go over to 6.2 and let's hope for the best. So on 31st January 2022, Tino deposits 1,000 Rand in an account that paid interest at 7.5% per annum, compounded monthly. He continued depositing 1,000 Rand on the last day of every month. He will make the last deposit on the 31st of December 2022. So in the same year, from Jan to December, he makes that deposit. Okay, so it's been 12 deposits thus far, with a monthly amount of 1,000 Rand. This is not a lump sum where we get to use the compound formula. This is an annuity because they are constantly depositing the same amount monthly on a periodic basis. Okay, so now the question is, will Tino have sufficient funds in the account on 1st January 2023 to buy a computer that costs 13,000 Rand? Remember, his last deposit is 31st December. 1 January is literally the following day. Okay, don't think it's another month where the money got time to mature. No, he on the 1st of Jan, the following day after the 31st of December, he wants to see, will he be able to buy the computer or the laptop? Yeah, to buy a computer that costs 13,000 Rand. So we want to find out what the amount will be. Okay, so because it's an annuity, X is equal to 1,000 Rand. N is equal to 12 because it's every month. And interest is 7.5% per annum compounded monthly. Okay. And remember, this is a future value question because this is something that he's investing. He's not taking out a loan, so he's going to get it in the future. So we have to use the future value formula. And you don't have to know it off by heart. It helps to, but it's there, provided in the formula sheet. Okay, so we have f is equal to x. Let's see. Oh, now we can erase. 1 plus the interest rate to the power n minus 1, and it's all divided by the interest rate. Okay, let's go back to our question with all the values. Here we are. So we know that x is 1,000. 1 plus 7.5%. I know in class they probably taught you to write 7.5 divided by 100. It's up to you. I just prefer putting it like this. So it's just really a personal preference. N is 12 minus 1. I guess it also depends on the calculator that you're using. If it's a whole lot complicated, rather just use 7.5 divided by 100. Okay, so let us go ahead and calculate what the future value will be. So we have 1,000 and 1 plus 7.5%. Don't forget to put in that percent if you are going to use or write it the way I'm writing it. And then to the power 12 minus 1, close brackets, divided by 7.5% divided by 12. Ish, Ambor. Okay, so he would have gotten 12,421 and 22 cents. That is not enough. He needs 13,000 rand. So will he have sufficient funds? No, because he is, or rather let's just write, Tino is short, because in this day and age we can never know if we have a male or a female. Okay. But they did say, will he? Yes, he will. But let's just be safe. No, Tino will be short of, let's see, 13 grand. He'll be short of 578 rands and 78 cents, unfortunately. But I mean, if Tino is still under his parents' roof, we can go ask his parents, right? Or just wait another month. Be patient. You don't have to get it immediately, okay? Unless if it's for varsity. Okay, so that's 6.2, a nice 4 marks. And we can go now to 6.3. It says Tabo plans to buy a car that costs 250,000. By the way, cars that cost 250,000 in this day and age, you're like, what? But I want to golf. No, you can't get a golf for 250. Well, it depends how old it is. Anyway, so Tao plans to buy a car that costs 250,000 rand. He will pay a deposit, which is quite good. It's good to pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per, guys, that's a high interest. 13% per annum compounded monthly. That's a lot. That is a lot. But it's better. When I started working and I didn't have a credit record, they charged me like 19.5%. And I was like, hell no, let me go take out a an Edgar's card thing and see if I can build up a credit score. It's a messed up society, messed up financial system, if I were to tell you. So anyway, what do we have here? We have a loan that costs 250. He's taking out a deposit. The interest is 13% per annum compounded monthly. Now 6.3.1 says calculate the value of the loan. Remember he took out a deposit, right? So the value of the loan is actually 250,000 minus 15% of the 250,000. Okay. Or you could have said basically the value of the loan, 100 minus 15, it's 85% of 250. Either way, you're going to get the same answer. So we can say, let's do the first one, 250,000, not 2.5 million. minus 15% of 250,000. So that is, there you go, 250,000. Did I put a million here? Yes, I did. So the value of the loan is 212,500. Okay, sorry. So otherwise you could have said 85% times 250,000, and you can still get the same 212,500 rand. 1 mark, as expected. If they gave you guys 2 marks, I would have been like, wow, they're quite generous. So 6.3.2, the first repayment will be made 6 months after the loan has been granted. Guys, if they offer you this deal, please don't. So it happened to me. I started paying 3 months after I got the loan. And I was thinking, everything is sitting still. No, nothing is sitting still. Money is never sitting still. While you're waiting for that 3 months to pass, or 2 months to pass, and then on the third month you start paying the value of the car, the interest on it, the repayment, it increases because money doesn't sit. So they say, you can start paying after 6 months. It's okay. It's not frozen. It's still accumulating interest. Okay. So the first repayment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. So if the first repayment is made 6 months after, it means for 5 months he wasn't paying anything, right? Thabo. Ne? Thabo wasn't paying anything for 5 months. He only started paying on the 6th month. So what happened for this 5 months? The value of the loan changed. It increased. So we need to find out what that value is. Okay? Because the bank needs to make its money. So the value of the loan, which was 212,500 rand, we have 1 plus the interest, which is 13% per annum, compounded monthly, and to the power 5. So this is what happened in 5 months. How much did the money grow? So we have our answer there, and then 1 plus 13% over 12 to the power 5 months. Yes, so it grew. You might say, it's not that much, but it is a lot. From 212 to 224,000. That is quite a lot. So 224,262,53. Do not delete this answer from your calculator. Keep it in. Okay. Now we can then say, we can then calculate the monthly installment that is required. Okay. So now, and this is a loan, so let's go to the present value formula. So we have P is equal to X, 1 minus 1 plus I, negative N. Okay, let's talk. We're looking for X, right? This is what we're looking for. P is this amount over here. I, we already have it, it's 13%, right? Divide by 12. N, what happens to N? They said he's going to take it over 16 months, but because he didn't pay for the 5 months, what is 6 years? 6 years is 60 months. No? Let's just make sure. 6 times 12. No, 72. Not bad. 5 years is 60 months. So 72 months, but you're subtracting the 5 that he wasn't paying. So you have 67 payments. So N is 67. Okay, so somewhere you write it down for yourself. And then now let's just put in the missing values. So you have 224,262 rands and 53 cents. Did I just remove my answer? Okay, there it is. Let's just write down the full answer. so that our answer at the end is not watered down. X is what we're looking for. 1 minus 1 plus the interest rate, which is 13% over 12 to the power negative, right? Remember what it is? It's 67. And we divide it by the interest, which is 13%. The interest rate didn't change. That's still 13%. Yeah. So the only unknown that we have is x. Okay, so we're gonna do some hectic calcs here, moving things around. So you have 224, 262, comma 5254, and we're multiplying it by 13% over 12. And then we're gonna divide it by 1 minus 1 plus 13% over 12 to the power negative 67. Guys, you have to make sure that you don't make a mistake because anything can happen. Okay, let's try putting all of this into the calculator. It's going to be hectic. 224, 262, 5254, and we are multiplying it, another fraction, 13% divided by 12, all over. Let's put in the brackets. Let's go back in. 1 minus other brackets. Let's go back in. 1 plus 13%. Okay, divided by 12. If you have a Casio, you can do this. Other calculators, I don't know, hey? Moment of honesty. Okay, so the monthly repayment is 4,724 rands and 96 cents. Is that it? Yeah, 5 marks. Think it was worth it. And we're done with the financial part. I hope you learned something. Please, when you take out a loan, try to have a very big deposit and don't start paying months later. You've seen the effect. Okay, try to get a loan that is quite low. I would tell you which bank offers, but they need to pay me to advertise them. Do your homework. Try different banks. See if it's necessary to really build up a credit record, but try to lower the interest when you're taking out a loan. And if you are investing, try to get the most out of it. Okay, let your money work for you and not the other way around. And that's it for this lesson. Bye.
Well, welcome to MV Tutors. My name is Fiagasha Manana, and we're still doing the mathematics paper, November 2022, paper 1. On question number 7 now. Let's get right into it. 7.1 says, determine the derivative from first principles. Okay, so we know 7.1, the derivative from first principles, okay, is limit as h tends to 0, f of x plus h minus f of x divided by h. What does this mean? It means where we have an x in the equation, we substitute that. So I'm just gonna do that here right now. Let's start with it. Where we have an x, we substitute x plus h. So the equation is x squared, so that's an x, so we'll open a bracket and put x plus h squared, and then it's a plus x, so where there's an x, we put an x plus h, minus, okay, minus, well, now we just put it exactly as it is, as f of x, which is x squared plus x. Please be careful to put it in a bracket and put the minus outside the bracket. Okay, now we divide everything by h. Now all we have to do is expand that. Unfortunately, we keep having to write this limit thing. Okay, so I like to, when I expand this, I like to actually put two of them, you know, just to, this will look untidy. But just imagine with me, I put another one here, x plus h. I'm just getting rid of this 2 and putting another one because that's what it means. So it's going to be x times x, which is x squared. And then it's going to be x times h, which is going to be plus xh. And then it's going to be h times x, which is plus xh again. And then h times h, which is h squared. On this side, it's just going to be plus 1 times x is plus x, 1 times h is plus h. This side, it's minus 1 times x squared, which is minus x squared, and minus 1 times x, which is minus x. Now, that's the proper way of doing this thing. Okay, and divide everything by h. Okay, I actually didn't need to open this bracket, so I'm just going to remove it as h tends to 0. Combining like terms, I've got x here. You can see it. This x minus that x, so that's 0. Now I've got x plus h plus x plus h, which is 2xh, right? And then I've also got h squared. Okay, before I go to h squared, let's deal with, I've got an x here, and I've got a minus x here. They cancel each other. And then I've got just a normal h here. It's the only one, so I'll write that one. It doesn't cancel. And then I've got an h squared plus h squared. Now that covers everything. Yeah, I think we've dealt with everything on top. Cool. We need to continue on this trajectory. Unfortunately, we keep having to write this thing. So now what we can do is actually factorize, take out h as a common factor, because this one has h, that's an h, and that one has an h. So for this one, it's going to be just 2x. This one is just going to be plus 1. This one is just going to be plus h, right? And then divided by h. Look what happens now. This h cancels that one, and then I'm left with, yes, you guessed it, I'm left with 2x minus plus 1 plus h. Now I can substitute where there's a h, I substitute as 0. That's a 0. So to complete this, so that I will have 2x plus 1. Where there's an h, I substitute a 0, which means now from first principle, f, the derivative of f of x is therefore what I'm left with, which is 2x plus 1. There we go. Let's do 7.2 now. 7.2. And it says find the derivative of that. So we've got f of 8x is equals to 2x to the power, what number is that? That's 5 minus 3x to the power 4 plus 8x. Now for the derivative, okay, bring down the 5, it becomes 2 times 5, which is 10x, and then 5 minus 1, it's 4, minus 4 times 3, that's 12, x 4 minus 1, that's 3, plus 1 times 8 is 8. 1 minus 1 is 0. Anything to the power 0 is just 1. So they leave it as that. Oh, nice and sweet and short. It's complete. All right, let's go to 7.3 now. It says the tangent to g of x, that's the formula of g of x, has a minimum gradient at the point. Okay, so they're actually telling us where the minimum gradient is. For which values of x will g be concave up? Okay, so here's what we know. We know that the second derivative of g of x is concave up, where, the graph g of x is concave up where the second derivative is greater than 0. So that's the end goal, which means we need to find the derivative of this until we reach the second derivative. So let's start with the original function, which is ax cubed plus 3x squared plus bx plus c. Now, come on, let's go for it. First derivative. It's gonna bring the 3 down. A times 3 is 3a x, and then 3 minus 1 is 2, plus we bring the 2 down. It's 3 times 2, which is 6, and then 2 minus 1 is just 1, and then this one, it's 1 times b, which is just b. 1 minus 1 is 0. Anything to the power 0 is 1. This is the first derivative. We gotta go second time now. Let's go. 2 of them. Okay, so we bring the 2 down. It's 3 times 2a, which is gonna be 6a x. 2 minus 1 is just 1, which remains, plus 1 times 6 is just 6, and the x goes away because anything to the power of 0 is 1. So there we go. We got that. But now they tell us that at that point, minus 1 and minus 7, that's where we have the minimum gradient. And we know that this is a formula for gradient. So we can solve, we know that we get the gradient where this is equals to 0. And we know that the answer is going to be minus 1. Okay, we know that the turning point or the minimum gradient is going to be at minus 1. And that's where g of x is equals to 0. Okay, so think of it this way. The gradient here, that's where the gradient is at that point, the turning point, and that value over there is that gradient there is actually 0. That's why we put the gradient as 0. And then we have 6a, and we know that that value there is minus 1, the x value. So we'll put minus 1 right over there, plus 6, just like that. Okay, so why did we do that? It was to help us to solve the value of a. So we'll just do gymnastics now. Bring that 6 this side, and then we're left with minus 6a. Divide both parts by minus 6, which means our a value is actually 1. Okay, so now that completes. We'll just substitute on the second derivative there. we'll just substitute the 1 there so that we have 6x plus 6. Okay, we've substituted a for 1. Now, watch this carefully. Remember, we said the graph is going to be concave up if we have an inequality where the values of x are greater than 0. The second derivative is greater than 0. So that's what we're going to do now. We're going to say just that it's greater than 0. Okay, and then we'll plug in that formula, which is 6x plus 6 greater than 0. When we do gymnastics, we'll just take that 6 to the other side so that it becomes minus 6. And then the value of x will then divide both sides by 6 will be then minus 1. This is our final answer. So it's going to be concave up for values that are greater than minus 1. That's the whole point of this calculation. Well, thank you so much for tuning in. I do hope you understood. But if you did learn something today, please like and subscribe to our channel. We really appreciate it. Also share with your friends. Okay, that would be good. Okay, other than that, goodbye from me and enjoy the rest of your day.
Hello everyone and welcome to MV Tutors. We're looking at question 8, and without wasting more time, let's get straight to it. Where I am, it's getting a bit dark, so we need to write as fast as we can. So we have a graph of y, which is the first derivative, and we see that this first derivative function is actually a quadratic function, which is drawn below, meaning it came from a cubic function. Okay, anyway, so the graph passes through points P, Q, and R. We can see those are the intercepts. The x-intercepts PQ and the y-intercept R. Okay, so you see we have a sad face parabola. A sad face parabola comes from a sad face cubic function. Okay, so these would be the intercepts of your parabola. Okay. Oh no, what am I doing? I just said it's a sad face. Now I'm drawing a happy face. So basically you have something like that. So this is where we have Q, that is where we have P. So they asked you to sketch the cubic function. This is how the cubic function would look. Okay, something like that. Obviously you do it much better, but they're not asking us for this. This was just for extra info. They are asking us in 8.1 to determine the values of m, n, and k. So basically we're looking for the formula for this quadratic function. Now if you have all your intercepts, you're going to use this formula over here. Okay, it depends what they give you. If they give you the turning points, you would use a different formula. I do cover this in the cubic functions video. Hopefully I remember to put in the link in the description below. I hope I remember. But if I don't, please someone type in the comment section like, Tsulu, you didn't put it in, like what's going on. All right, so we have that form over there. So firstly, you can put in your x-intercepts. Okay, so y would be equal to a, and we have x. So in the place of x1, you would put negative a third. Okay, so we're going to put in p here and q there. So that'll become positive a third. And then for q, we can put in 1. Then we can now put in the y-intercept, which is 0, 1. So in the place of y, we put 1. And in the place of x, we just put 0. And now our only unknown is a. So 1 is equal to a. And we have a third multiplied by negative 1, which is negative a third. And we are expecting our a to be negative because we have a sad face parabola. Okay, so a would be equal to 1 divided by a third, negative a third. So a is equal to negative 3. Okay, so we have the value of m. Let's go put it back in the formula. So we have negative 3x plus a third x minus 1. And we're going to have to multiply everything out. How many marks? Okay, 6 marks. Okay. I was about to say this better be worth a whole lot of marks. So we have x squared plus a third x minus x minus a third. Okay, let's simplify before we take out the brackets. So a third minus 1 will be negative 2/3. Please use the calculator if you're not sure. And then we can multiply in the 3. So we have negative 3x squared plus 2x, ne? Yes, and then plus 1. Yes, this 1. Yes, I agree. And so, yes, so the value of m, because that's what they asked us ultimately. So m is equal to negative 3, n is equal to 2, and k is equal to 1. And right there we get our 6 marks. Yeah, I like this. They're not stingy with the marks. I love it. Okay, 8.2. Let's just shift this a bit up. Okay, so if it is further given that f of x, oh, so this is now the original function. Okay, remember the first derivative is just your parabola. So now the original function, the cubic function, I told you, it is a negative cubic function. We have negative x cubed plus x squared plus x plus 2. Okay, so 8.2.1. Determine the coordinates of the turning points of f. Turning points of f are, what do you call this? Stationary points, right? Okay, so I get our f is looking like, okay, not exactly like this. Something like that, okay? So here you have a gradient, but as soon as you get to a turning point, your gradient is 0. That is your stationary point, okay? And here you start increasing, and then you get to this one here, it's flat. Gradient is 0. That's your other stationary point. So those are your turning points. Okay, this is the minimum one, and that is your maximum turning point. So what do we do then? We get the first derivative and we make it equal to 0. Okay, you don't have to work it out. It's 3 marks, but they've actually given you the x values. Remember, I told you that the turning points of your cubic function will be the x-intercepts of your quadratic function. And we already have those x-intercepts, okay? Don't go working hard unnecessarily. So determine the coordinates of the turning points of f. I have the x coordinates. 1, x is equal to negative a third. Therefore, we need to get the y value for it, okay? So this is p. And then q, we have that x is equal to 1. So what is the accompanying y coordinate? For those of you who didn't hear a single thing I said over here, it's fine. What you can do is you can go to your function f, get the first derivative, which you determined in the previous question, and make that equal to 0. So basically, you're going back to this function, making it equal to 0, and you're getting your x-intercepts, which you already have. Okay? So, yeah. Now, after you get the x values, you're going to take that x value and you're going to substitute it back into the original formula. Okay? And the original formula is negative x cubed, blah, blah, blah. So, in the place, we have negative, and then in the place of that, we have negative a third cubed plus negative a third squared plus, which guys, my son is getting his first haircut professional and he's busy crying. So I'm trying to be serious here and solve this sum, but another side of me is like, go check out what's happening. Okay, so if we have negative a third, our y value becomes 1,81. Did they say anything about? No, they didn't say anything about fraction form, or let's just put it both answers. So 49 over 27, which is really equal to 1,81. So therefore, okay, let me put it here. Now I don't have space. Therefore, oh, here he comes. P is negative a third and 1,81. Now I'm going to calculate Q. If we have 1, hello. Ooh, oh, Chama boy. Go say thank you to Uncle Fairhope. He looks cute. It was worth the tears. Oh yeah, he does look cute. I must say so myself. So I cut my hair and he's like, Mommy, why did you cut your hair? Now you look like a boy. I don't like it. Go get long hair. I'm like, hey, wait, nah. Hairline, yo, can I please recover my hairline? Please. Yeah, so I'm in a family with boys only and they want long hair. Okay, cool. Now, if we substitute x is equal to 1, we're going to get y is equal to 3. So now our q coordinate is 1 and 3. So we have then for 3 marks the coordinates of the turning points of f. Now let's get to 8.2.2. Draw the graph of f. Hey. So you already know how it looks, right? Draw the graph of f. Indicate on your graph the coordinates of the turning points and the intercepts with the axes. So if you don't really know how to manipulate it, please just I'm looking for the snippy tool. Just go and use your table function in your calculator, okay, and just go ahead and sketch it from there. For me, I'm gonna try to draw it from this parabola. Okay, so now it has gone all the way up. Okay, patience. It's gonna have to go to the other page. Let's shift it a bit down. Okay, so basically I am going to extend the y-axis, and I know that, let me just make this page a bit smaller. I know that the turning point of my parabola is the point of inflection of the graph. Remember, I'm expecting a graph like this, okay? And then my intercepts of my parabola are my maximum and minimum turning points of my cubic function. But what do they want from us? They want to have turning points, intercepts with the axes. Okay, so P was negative a third and 1,81. So I'm just gonna say that's 1, that's 2. So somewhere around there. That's P, okay? And then Q is 1 and 3. So 1, oh gosh, so 3 somewhere up there. I didn't plan my stuff correctly, but it's all good. Let us see what we work with here. Let's say that's 3, and that's 1, so that's Q. Okay. And then no. I just said this is where Q is. My bad. The middle line is the inflection point. Okay, so our graph, I still need to calculate the x-intercepts and the y-intercept. And how many marks? It's 5 marks. Okay, so basically, if that is my minimum over here, it's going to do something like this. And then that's where it turns and becomes, okay, so okay, yeah, it's gonna be something like that. Okay, but I need to go calculate the x-intercept over here. Sorry, y-intercept, x-intercept, but from the formula, the x-intercept is 2. Okay, let's start this. The y-intercept is 2. Did I say x-intercept? The y-intercept is 2. Okay, so it comes like this. Then it does. Q is the turning point over here, which is 1 and 3. And we have P, which is a third, and a number close to 2. And here we have 0 and 2. So P is negative a third, 1,81. And now I need to get an x-intercept over here. So x-intercept, basically y is 0. Let's just make this bigger again. It looks weird now that I've enlarged it. Okay, I think I'm also going to go to the table method and try to get it from there. I'm not going to go and try to calculate. Okay, but it's 5 marks. Oh gosh. Okay, guys, I'll be back with the synthetic division so that we can get our x-intercept. Okay, my weird looking function. I'm gonna use, I said I'm gonna do synthetic division, but we only need one x-intercept. So I'm gonna use the table function like I initially wanted to before going over to synthetic division. You can watch that video as well of how we do synthetic division. It's because I took so much time trying to draw the graph by looking at it. So I'm just gonna do this. So we've written in the function. Let's start at -2. Let's end at 5 in steps of 1. And we can see -2, we have 12, -1, we have 3. At x is equal to 0, we have 2. Yes, that's correct. At 1, we have 3. Yes, that's our turning point. Ah, okay. So this is 2 and 0. Okay, I feel like this function is very ugly. But you get the drift, right? You catch the drift. This is how it looks. If I were to draw it pretty, it would look something like this. Okay, we have your point of inflection. We don't really know what it is, but it doesn't matter. Point of inflection, but yeah, we have our turning point there, negative a third and 1,8, right? This is the pretty version. Then we have our value there, the point of inflection, 0, 2. Point of inflection is basically where it goes from concave up to concave down. And we have, oh no, we don't know what the point of inflection is. Sorry, we don't know it. We didn't calculate for it, nor did they ask for it. Our y-intercept is 0, 2. Okay, point of inflection is somewhere here. They didn't ask for it. And then, yeah, this is P, that is Q, and Q is 1 and 3. And then our x-coordinate over there, x-intercept rather, is at 2. So that's how I would sketch the graph. A nice looking graph. Not the disaster that I drew up there, but I hope you followed me. I hope you understood. I hope it was clear. Okay. Better looking graph, ne? Yes. Okay, cool. We did everything, ne? We drew the graph, coordinates of the turning points, intercepts with the axes, so we're good. Now 8.3. Guys, to be honest, I'm seeing these questions for the first time. So you can see what I prepared at all. What's us back? Okay, points E and W are two variable points on f prime. So basically on our parabola, right? Remember this parabola that we have over here? Yes, that one. Okay. So we have E and W points on the parabola and are on the same horizontal line. Okay, now H is a tangent to F at E. G is a tangent to F prime at W. H and G intersect at D. Write down the value of A. Oh, A, that's for D. Okay, so basically, let's read this again. Points E and W are two variable points on our parabola and are on the same horizontal plane. Okay, cool. Now H is a tangent to F at E and G is a tangent to F at W, F prime, H and G intersect at, and if the value of A, that's just one mark, we shouldn't be thinking too much about it, no? Okay, 8.3. Points E and W are two variable points on F prime and are on the same horizontal line. Okay, that can be a bit confusing. Where is F prime? So F prime is our graph over here, the parabola, the quadratic function. The only horizontal line that we're seeing on this function is the x-axis. So if they say points E and W are two variable points that are on the same horizontal line, it means that E could be here, W could be there, or E, because it's on the east, W is on the west, it's there. Like, it can be either or, okay? And so, if that's the case, yeah. So now H is a tangent to F prime at E. G is a tangent to F prime at W. Maybe this is E, because we normally start with E as we read it, okay? As we read it, it is, yeah, it doesn't matter really, unless they tell us to work it out. But yeah, so we have tangent lines, and then H and G intersect at D. All right, so for that, I'm just going to use straight lines, because if I try to draw it, I won't finish. I will want to draw it perfectly and not get to where I need to get. Okay, so then we have another line. Let's see, illustrations, shapes. That's the one that I want. Okay, there we are. Okay, so you can see the tangent is not exactly where it needs to be. Tangent should be there, but let's just pretend like it is tangent at E and W, okay? And this is where D is. Let's not waste time trying to make things perfect. Okay, so that's what we have. That's the scenario that we have. So 8.3.1 says, write down the value of A. So A is the x value of D. And I hope you can see that actually A is our turning point. And remember, we have the equation for f prime. It was negative 3x squared plus 2x plus 1. Let me just make sure. Actually, we can look at this one. Negative 3x squared plus 2x plus 1. Yes, if we find the derivative of f. So there we have it. So your turning point formula, a, in this case, which is the x value, it would be minus b over 2a. So minus b, that's minus 2 over 2 times a, which is minus 3. Minus and minus cancel, 2 and 2, they cancel, so we have a third. And that's basically a, and that's 1 mark. You might have said, yeah, but we did quite a lot. Maybe 2 marks, but it's 1 mark. Otherwise, you could have just said, okay, this is 1. Okay, this whole value over here is 1, and we have a value of a third. So can we just get halfway? And if we get halfway of that, it would basically be 1. It's like getting the average. Okay, getting the average of 1, okay, plus a third divided by 2. I want to say 1 minus a third divided by 2, because I'm taking the position here, which is 1, and I'm adding negative a third. Okay, so a third is the value of a, but I would go with this formula here, really. Do tried and tested formulas, but it's 1 mark. 1 mark that can be a difference between a distinction and a pass. Ne? All right, 8.3.2, determine the values of b for which h and g will no longer be tangents to f. Okay, let's look at our tangent lines over here. When would they not be tangents? Okay, firstly, let's get the value of b. B is the y value. Okay, so the y value, if we then take negative 3 and plug in a, which is a third, squared, plus 2, a third, plus 1. So we get negative 3, a third, squared, plus 2 times a third, plus 1, and that's 4 over 3. That's the y value, 4 over 3. So now they're saying determine the values or value of b for which h and g will no longer be tangents. So if this y value here, if we extended this line, is 4 over 3, which is 1 and a third, if we took it down, okay, let's just say we took it down over here, and they're still intersecting like that, okay, or we take it even lower, then they're no longer tangents. Do you see that? They now intersect the graph of f prime. Okay, so basically b can be smaller than 4 over 3. What about b being larger than 4 over 3? If b is larger than 4 over 3, we still need to make sure, man, my page is finished. We're there at the top. Okay, so this is some slightly bigger. Okay, it also won't be, yeah, but we can still take it up. Let's just say we shifted this a bit. Okay, and we have this over there, and it's basically bigger. So it won't be tangent anymore. But the more we go up from 4 over 3, I hope you are getting me and what I'm trying to demonstrate over here. If this was 4 over 3 previously, let's just pretend this was 4 over 3. Okay, if we go higher than 4 over 3, it will no longer be a tangent as well. But they're still meeting somewhere on top. Okay, so I think b can be smaller than 4 over 3, or b can be bigger than 4 over 3. That way, h and g will no longer be tangents to f prime. That's just my guess. If they said the length of h and the length of g has to remain as it is and must not cross or something. I don't know. There aren't really a lot of restrictions that can say we can stick to only one answer. I think it can be either B is smaller than 4/3 or B can be larger than 4/3. Oksalayo, they won't be tangent to the graph anymore, whether it's higher or lower than 4/3. Okay, and that is your 2 marks. And I believe we're done with question 8. Thank you for tuning in. Hello everyone and welcome to MV Tutors. I'm Solo and I'll be taking you through to the last 2 questions. Let's start with question 9 first. And yeah, I hope you guys are doing good in this cold autumn. This month of May, that is just, we're having all weathers at the same time. And thank you for liking our videos, subscribing to our channel. Please don't forget to comment below if you have a simpler way of doing things, or if you see hey girl, what you were saying is not make sure, so that we can make sure that everybody understands, right? Because math is fun. All right, so question 9, it says given we have f of x is equal to x squared. All right, so we have a parabola. Now it says determine the minimum distance between the point 10, 2 and a point on f. So for all those visual learners who are like, okay, what is going on? Let's say you have your function, okay, and it's y is equal to x squared. And then right there you have a point, let's say that is 10, and over here you have 2. So you have your point with the x coordinate of 10, a y coordinate of 2, and you want to know the minimum distance between the point and the parabola. So if I were to put a straight line, basically this would be your minimum distance. Okay, let's stick to black. What happened? Just disappeared. Okay, if it were to be your maximum distance, then it would have to go all the way that side. No, something like that. Or maybe it's up there. We don't know. Or maybe the minimum is here. Like, we really don't know. Okay, but we do know that wherever that minimum point is, you have x and y, because we don't know. All we know is it's a positive x and it's a positive y. So how are we going to start this? Okay. So already when I saw minimum distance being the key word, I was like, okay, we're going to use the distance formula. Okay. And what does the distance formula say? So let me just make this a bit bigger. Okay. So the distance formula says d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. All right, so I will take this as 0.1 and I'll take that as 0.2. All right, so x2 is basically 10 and x1 is just x. y2 is 2, y1 is y. But here's the thing, I have one equation and I have 2 unknowns. So I need another equation so that I can just have one unknown. And for me here, because I know that y is equal to x squared, if x is x, then y is just going to be y squared. So basically I hope I'm making sense, but basically I can rewrite this as x, and in the place of y, I have x squared. Okay. So then I'm going to rewrite it again and say 10 minus x plus 2 minus x squared, and that is squared. So if I were to take out the brackets, what do I have? I have 100 minus 20x plus x squared. plus 4 minus 4x squared plus x to the power 4. Okay, let us simplify it. So we only have 1 x to the power 4, and then I have negative 4x plus x, so I have negative 3x squared, and then there's a negative 20x, and 100 plus 4, I have 104. And remember, that's my distance squared. Okay, so now we have the distance. Well, not really, it's in terms of x. And when they want the minimum distance, whenever they say minimum, maximum, what should click is that we need to differentiate. Okay, we need to get the derivative. So the derivative in terms of x, 4x to the power 4 minus 3x squared minus 20x plus 104 would be equal to, just going to write on the next page. Okay, if I start with x to the power 4, I bring down the 4 and I subtract 1 in the exponent. So I have 4x cubed, and then I have minus 6x, and I have minus 20. Okay, and that is all equal to 0 if I want to get the minimum. Okay, or maximum, but they asked for the minimum. So now I need to solve for x. All right. And we have a cubic function. Okay, firstly, let me just simplify it. I'm going to divide by 2 throughout. So I'll be left with 2x cubed minus 3x minus 10. Okay. So in this case, guys, we're going to look for that one factor that will give us 0. Okay, I normally start with 1 and then negative 1, then 2, and then negative 2. So let's start with 1. I have 2x cubed minus 3x. It's always nice to put it in brackets so that you don't make any mistakes. So 1 doesn't work. If we try negative 1, doesn't work either. Okay, let's try 2. Okay, so 2 works. So then, so x is equal to 2, right? Therefore, one of the factors is x minus 2. And then I have this huge bracket where I would have probably 2x and 5 over there. That will give me minus 10. So I need to get the middle term. And it's up to you at this point if you want to use a long division or synthetic division. So if you're not sure about synthetic division, please check out our video. But basically, we're going to look at the coefficients. Okay, for x cubed, we have 2. X squared, we have 0. Excuse me. For x, we have minus 3. And then we have minus 10. And we know that 2 is one of the factors. So firstly, what do? We bring down the 2. And then 2 times 2 is 4. Okay? So 0 plus 4 is just 4. Then 2 times 4 is 8. Minus 3 plus 8 is 5. 5 times 2 is 10. Minus 10 plus 10 is 0. Guys, if you do not get 0 here at the end, it's late. Okay, so we have 2x. All right, 2x squared plus 4x plus 5. Okay, so there we got it. We have one solution where x is equal to 2. Let's see, can we get a solution here? You can go and try to use the quadratic formula. It might take time. I would want to test first. Is it worth our time? Remember the discriminant, which is basically b squared minus 4ac. So in this case, b is 4. So we have 4 squared. And then minus 4a is 2, c is 5. If we get a negative here, don't even bother solving it. There is no root, okay? So your parabola here is probably somewhere floating in the air. Okay, so let's see. So we have 4. Oh, gosh. Okay, go to the calculator. have 4 squared minus 4 times 2 times 5. And we have negative 24. So in this case, there are no roots. So our only solution, which actually helps, imagine if we had a lot of solutions, we would have to substitute all those values to try to get the minimum distance. So x then is equal to 2. Okay, great. Now we can go back to our distance formula, guys. D squared, okay, is equal to, I need to go back up, x to the power 4 minus 3x squared minus 3x squared minus 20x plus 104. Okay, and then I know that x is equal to 2. So 2 to the power 4 minus 3 times 2 minus 20 times 2 plus 104. And I am going to root both sides so that I can get what D is, finally. Okay. So 2 to the power 4 minus 6 minus 40 plus 104 is root 74. I think it's better getting it and rounding it off to 2 decimal places. Oh, I did. So 8,6 0 units. Okay, did I do it correctly? Yes. Wait. Something doesn't look right here. 3x squared. What happened to the 2? 3x squared minus 20x plus 104. Okay, let's go back. So 3 times 4, which is 12. So I would get negative 12. Okay, so if I hadn't seen that, unfortunately, that would have been my answer in the test. I have nothing to test it against. It is what it is. So 2 root 17, which is then equal to 8,25. And it sucks rewriting things incorrectly and getting them wrong. So just please check your answers. And we are done with question 9. 8 marks. It was a good 8 marks. Okay, so see you later for question 10. Thank you for tuning in. Welcome back, and we have reached the end of the paper. Question 10. So yeah, let us finish strong. Yeah, let's do this. Let's finish strong, and I hope the preparations for the exams are going quite well. I hope you're keeping warm where you are. Some of us are just attacked by blocked noses and whatnot. But anyway, A, B, and C are 3 events. The probabilities of these events or any combination of them occurring is given in the Venn diagram below. So we can see we have an unknown X, which is within where all the events intersect, and Y, which is not part of any of the events. Okay, so let's start with 10.1.1. If it is given that the probability that at least one of the events will occur is 0,893, calculate the value of Y. So at least one will occur. At most, 3 could occur. Okay, so we see that if 3 of them occur, we get 0,893 at most. And if none of them occur, that's a complement of all the events that occur. Okay, so that's basically 1 minus 0,893. And we're just going to check that out on the calculator. Okay, so 1 minus 0,893. And that is 0,107. Or you can round it up to 2 decimal places if they prefer it like that. It's 1 mark. I don't think they'll be that strict. B, calculate the value of x, the probability that all three events will occur. So if all three events will occur, that's basically everything inside, right? That's the 0,893. But x, guys, x is there. So we're going to take 0,893 and subtract everything around it so that we can get x. So x is equal to 0,893 minus 0,05 plus 0,15 plus 0,05 plus 0,2 plus 0,183 plus 0,1. Okay. And let us get the calculator out. So we have 0,893 minus 0,05. I think there's two of them. Plus 0,15 plus 0,2 plus 0,183 plus 0,1. Am I missing something here? 0,15 plus 0,1. Okay. All right. So we get a value of 0,16. And that's it. That's x. Okay, that's b. And now we get to 10,1, 2. Determine the probability that at least two of the events will take place. So at most, three of them will take place, but at least two will take place. Okay, so if that's the case, probability that events, at least two, when just the probability at least two, I'm not going to write the whole sentence, at least two events occur. So basically, I could have the probability of A and B plus the probability of B and C plus the probability of C and A plus the probability of A and B and C, because I mean they said at least two, right? So you can have three at most. Okay. Now, probability of A and B, remember it's the intersection. So A and B will be 0,1 plus 0,16. So that's 0,26. And then B and C, 0,2 plus 0,16 is 0,36. C and A, 0,15 plus 0,16, 0,31. Ooh, should actually be using the calculator. And A and B and C is 0,16 because that's just x, and we calculated that previously. Okay. And we get 0,26 plus 0,36 plus 0,31 plus 0,16. Ooh, no, that cannot be correct. You cannot get a probability higher than 1. So what mistake did I make over here? Okay. Actually, I should be adding this up. Now, if that number was below 1, I would have confidently went away. This is what I should be adding. Okay, those values as they are, without adding the x to it. Let's try again. So it's 0,1 plus 0,2 plus 0,15 and plus x 0,16. If this is wrong, then I don't know. But how will I know that it's wrong? Okay, plus 0,15 plus 0,16. And you get 0,61. I think this looks much better. Yeah, it's better to visually see what I'm adding and use that instead of just calculate. Okay, so that's 10, 1, 2. Just fix my screen over there. Okay, so now 10, 1, 3. Are events B and C independent? Justify your answer. A nice 5 marks. So I'm going to take the probability of B and C. And C, if it is equal to the probability of B multiplied by the probability of C. So the probability of B and C will be 0.2 plus x, which is 0.16, and that would be 0.36. Yeah, I think my error, thinking about it now, I shouldn't have been putting this A and B, B and C, C and A, because as I wrote it here, what I did and calculated was correct, but I should actually just add, because if I say A and B, it means something totally different. So it's better to just shade over here and write the values as I did there. I hope I didn't confuse you, but I had to correct myself. So probability of B, that is basically everything inside. So if I were to take 0.1 plus 0.2, that's 0.3, plus 0.183 plus 0.16, I get 0.643. And I multiplied by the probability of C. So the probability of C is everything inside C, which is 0.15 plus 0.05 plus 0.2 plus 0.16, and that is 0.56. So if I take the 2 and I multiply them, 0.56 multiplied by 0.643, that is basically equal to 0.36. Never mind the last 2 digits or 3 digits over there. But yeah, if we take 0.56 multiplied by 0.643, we get exactly that, 0.36. So are events B and C independent? Yes, they are. Okay, because the probability of B and C is equal to the probability of B times the probability of C. And then now we're going to the counting principle 10.2. Okay, so a 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated, okay? They may not be repeated. Okay. Sorry, I'm still haunted by this digit that I found. Can I just check again the probability of B? So I have 0.183 plus 0.2 plus 0.1 plus 0.16, and it is 0.643. And I'm gonna multiply it by 0.15 plus 0.16 plus 0.05 plus 0.2. Okay, I'm still getting this. It is what it is. Let me just rest. I don't like that I got, yeah, no. Yeah, it is what it is. 008. I was hoping for a perfect 0.36. Sorry about that. 10.2. We have a 4-digit code. So what values are available for us? We have 0, we have 1, 2, 3, 4. Before we apply the restrictions, I know some of you are like, no, 0 and 1 are not included. Yeah, let's just deal with the 10 digits that we have originally. So they told us no repetition, right? And they also said it must be even numbered. So in this last block over there, you can either choose between 2, 4, 6, or 8. Okay? And they said we do not include 0 and 1. All right? So what option do we then have? Oh, we haven't even looked at the first question, but it says how many possible 4-digit combinations are there to open the lock? All right, so how many? We know that here we have 4 options, 2, 4, 6, 8. And once you have taken one of them, you have 3 left. Ne? So let's say you took 2, for example. Then you're left with these last digits, 1, 2, 3, 4, 5, 6, 7. Okay, so you have 7. Once you take that, you have 6. Once you take that, you have 5 options available for you to use. All right, so and how many marks is this? 3 marks. Okay, that's nice. So you have 7 times 6 times 5 times 4. So you have 840. I think another way you would have done it, but maybe let's not go there. If you have, no, let's not go there. I wanted to use that formula of the amount that you have and divided by the amount that you can actually choose from, but no, this is unique. You need to separate it. Okay. 10.2.2. All right. Calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. Okay, so 0, 1 are not included, so we have 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's talk now. The third digit is 2, so we cannot use 2 anymore. And then the first digit is higher than, we have to make sure it's 5 and above. Okay, so at our disposal, let me just do this. So 2 is available, so only have one option there. So here I can have 5, 6, 7, 8, 9. Okay, so I have 5 options. But the last one, it has to be an even number, right? That hasn't changed. So because 2 is taken, I only have 4, 6, and 8. Okay, so for me to do the sum, I have to break it down because I can't just say we have 5 options over here. Because what if I decided to use 6 and I can't repeat? Then I'll be left with 4. Okay, what if I use 8? Then I'm left, So we can't really put 5 over here. What we can do, we can break this down and say, I know I have one option here for 2. By the way, if I remove, so I have 2, and let's say I take out 4, for example, I have left 1, 2, 3, 4, 5. So I'll always have 5 options available to me for my second digit. For my third digit, there's 1 digit that I can use, which is 2. Okay, so I'll always have 5 over here. My last digit, I can use 4, 6, or 8. So I have 3 options available to me. And if I use 4, 6, or 8, I can't use 6 and 8 for my first digits. So I only have 3 available options. Okay, but there's also another combination. Okay, so if I were then to use 6, okay, so I still have 5 over here, I have 1 over there. If I were to use 6, okay, I'm left with 4 and 8, so I have 2 options. So it means there's 8 available here. Okay, because I didn't use, or rather, sorry, there's 6 available for me, not 8. So 6 is available for me to use, 5 is available, 7 is available, 9 is available, right? But actually I've already used 5, 7, and 9. So I have between 6 and 8. And if I use only 6 because 8 is somewhere there, then I only have 1 available option. I hope I didn't confuse you. We've already taken 5, 7, 9. I can't use it again. My goodness. Okay. And yeah, so I have 1 available, which is either 8 if I chose to use 6, or it's 6 if I chose to use 8. Hence, my third possible option is 1 again. All right, so if I chose to use 6 here, there was 8 that was available there. But if I chose to use 8, then there's 6 available there. So these are all the available options that can help me calculate the code. But remember, we're calculating probability here. So this is the first portion of it. So let's just get what that value is. So we have 3 times 5 times 3, and that's 45. Then we have 5 times 2, which is 10. We also have 5 times 2, which is 10. So that's basically 10 plus 10, which is 20, plus 45. That is 65. Okay, but they didn't ask for that. They asked for the probability. Calculate the probability that your digit or 4 digit combination will be higher than 5,000. So basically that would be 65, and that we divide by the total amount which you calculated in the previous question, and that's 840. Okay, so the probability would be 65 divided by 840, and that's basically what, 0,077 or 0,08, or maybe you would have used the fraction, which is 13 over 168. I don't know in what form they wanted, but this is where we part ways until we see each other for question, or rather paper 2. Okay, so we've reached the end of the paper. I hope it helps you to prepare well for your June exams. All the best with paper 1. Please don't forget to like our videos, to subscribe to our channel, and also just comment below if there's anything that was out. All right, bye.